right, we're looking at your notebook on page 5 right now, and you should have your little Albert Einstein glued at the top of page 5, and above his head, what is a scientist? And what I would like for you to do right now is I'm going to pause the video, and I want you to brainstorm as many words as you can think of that describe what you think a scientist has to be. So think of his descriptive qualities. If you look at the large version I have up here, notice I have the word observer already written down, because one of the qualities I think a scientist needs to have is they need to be a good observer. So if you will jot those down, I'll give you, like I said, I'm going to pause the video, and we're going to take a couple of minutes for you to do that, and then I want you to share those with your partner that you're sitting with. Now, I would like your table group, so if you're group 1, the 4 of you that are 1, you're group 2, the 4 of you that are group 2, I want somebody to take a pack of Post-it notes out of the bucket and be the recorder, and I want each person to give one characteristic that they believe a scientist has to have. So you should come up, so basically you're going to fill out 4 Post-it notes, recorder, and then I want you to bring them up here and we'll put them on the big scientist. So again, we're going to pause the video for a second while the group comes up with their list. Now, we're on page 4, and I have given you this legal sheet. Notice that you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different blocks on here. Now, I have not passed out the stapler yet for this, because I think you really probably want to get this complete before you staple anything in. Okay? So I just want you to write page 4 at the top, and I want you to identify this as your Frater card, Skills of a Scientist. And we are going to do some of this together today, and then you are going to finish this tonight for homework. And if you don't finish it tonight, you're going to have to finish over your long weekend, because I am going to check that you have something in every box. Now notice one box has been done for you on all of these, but the characteristics, the sketch, and the example are all blank. And so we're going to get a little bit of this done now, and then you are going to have to get the rest of it done tonight and tomorrow night. And hopefully you will get it done tonight, and then it won't be homework over the weekend. Now I'm going to switch screens. All right, so we've just looked at Einstein up here and thought about the skills that scientists need. And I want us to apply these skills to ourselves and our lives. Because when you come to science class, I want you to think like a scientist. And I want you to process information that way. I want you to be an excellent observer. And so we're going to look at some of these other skills that you have to be successful as a scientist and to be successful as a student in science this year. So, if you're following along on your Frater cards, in the first square, or find the first square that has observation, because that's where we're going to stop, with observation. Now, notice I have given the definition for you, and the definition of to observe, or observation in the noun form, is to use your senses to gather information about an object or event. And this is called qualitative data. So let's talk about a couple of things to begin with. Senses. What are your senses? So, we have the sense of sight, we have the sense of smell, we have the sense of taste, we have the sense of touch, and we can hear. Now, very rarely is the scientist going to use the sense of taste unless you're a food scientist. But we are going to use the sense of smell. We're going to use the sense of sight. There are some chemicals that have very distinct noises that they make when they interact with other matter. We will use texture. You think about texture of some objects. Texture is very important when you talk about Mohs scales of hardness and rocks, if you remember from 6th grade. But all of these are ways to gather information about a substance or an experiment that's happening as you're watching things change. And this is called qualitative data. Now, what word or word root do you see in the word qualitative? So observations are considered data because they are descriptive, and qualities are descriptive. You have blue eyes or brown eyes, you have short hair or curly hair, you are tall, you have on a blue sweater today. Those are all qualities that describe you. So when we're talking about observations, we are talking about things that are descriptive. So what is all the information you can gather using your senses? Now, if you look at the cards, sketch is one of the blocks. And I used a magnifier for my picture here. So you can draw a magnifying glass, you can draw an eye, you can draw an ear, you can draw whatever you want for your sketch to help you remember what the definition of observation is. So we're going to pause and give you a chance to get your sketch done. Now, the example, I want you to come up with an example from science class of where you would use these skills. Now, for observation, let's talk about what our examples could be. So let's take some time to see what some people think they might observe during a science experiment. All right, and then the box characteristic, I want you to write a sentence using the word as either in the noun form, observation, or in the verb form, observe, and your sentence cannot restate the definition. So again, we'll do this one together. So we'll pause for a minute and talk about what sentences we might use either observation or observe in. Now, as we go through the rest of the skills today, the definitions are done for you. So I want you to follow along. You can add the sketch. I have a picture given. You can use my picture, or you can come up with your own picture. So when you leave class today, you should have a sketch in all of your frater cards, and you should have observation, all 4 boxes filled in, and then that only leaves you coming up with a sentence and an example for homework over the next few days. So the next term is order. And when you are putting things in order, you are putting them where they belong. If you've ever done an Excel spreadsheet, you know you can put things in ascending order or descending order. Can anybody tell me the difference between ascending and descending? I have you seated right now alphabetically, A to Z. So that is an order. That is a logical sequence. So if you notice in my picture, I have the folks lined up from tallest to shortest, my little stick people. The next term is classify. And classify is very similar to order. It's another way of logically arranging things. But when we classify, we are going to separate the scientific ideas or objects or events or animals or plants or chemicals into distinct categories. For example, when you look at a periodic table, it can be in this distinct categories of metals, nonmetals, metalloids, synthetics. So those are distinct categories. When we think about the kingdoms of life, we have the animal kingdom, we have the plant kingdom, there are two bacteria kingdoms, there's the protist kingdom, there is the fungi kingdom. So we have different kingdoms. So as things are classified, they're placed into distinct groups. And what could I used a filing cabinet as my picture for classification. Because in a filing cabinet, each of my files are organized. They're usually in order and they are in classification. So I have them in like A to Z order, whatever my classifications are. And then I have them divided up by the different topics. So for example, my science files are divided up by my units. So my chemistry unit would come first because of the alphabet C. I've got this unit is called my skills unit. So it would be in a folder farther back in the file cabinet. Now, the next term, I'm sure you know the definition of, hypothesis. That is, what do you think is going to happen before the experiment starts? So based on your prior knowledge, based on your looking at the chemicals or the equipment or the objects that you're going to use in the lab, based on what you have been told the purpose of the lab is, what do you think is going to happen? Now, if you're designing your own experiment, you might have to do some research before you make your hypothesis. Most of the time in our class, you're going to be given some background information before you start the experiment. So that's going to help you come up with your possible hypothesis of what you think is going to happen. It's often called an educated guess. And that keyword education is in there because it means you've thought about it. It's not random. Now, and sometimes you're going to find out that your hypothesis is correct. Other times you're going to find out that I got it wrong, but I still learned something. So it's okay if you don't get your hypothesis right as long as you have learned something and can analyze the information at the end of the lab. So I'm using a question mark as my picture for a hypothesis. All right, the third term is a graph. You have done lots of graphs in math classes. You've probably even done some bar graphs in social studies classes. Hopefully you have definitely graphed in science. And we're going to spend several days talking about graphs and what the expectations are for a scientific graph. But a graph is a picture of your data. And so as you can see, I have done shown you a graph here with a curved line. So the data is positive. As one variable increases, the other increases. I've also done it in a chart form, which could be another way to picture your data. Now, an inference. An inference occurs after you have gathered your data. And you can gather numerical data from things that you have measured in the experiment. You can gather qualitative data. You've seen bubbles, you've smelled an odor, you've heard a popping sound, you've watched something change before your eyes. So inferences are what is your interpretation or analysis of what you gathered in the experiment. And so I have two pictures here. You can pick which one. He's combining chemicals and making inferences about what is happening when he does. Or I have the Pink Panther, and there was a movie many, many years ago called The Pink Panther, and it was about a detective. And detectives are really good about inferences. They collect evidence, which would be data at a crime scene. They interview witnesses, so that would be qualitative data that they collect. They then put together the information from the witnesses and from the crime scene technicians, and then they analysis of all that crime scene data, and then they draw or make some inferences about who committed the crime. And once they have that together, then they go out and place someone under arrest for trial. So I use the Pink Panther as a detective as my inference, because detectives make a lot of inferences. Now, you've all done an experiment. So obviously, I used a picture of the Bunsen burner and some chemicals and some things happening as my example of an experiment. But that is an investigation in which you have some controls, things that you are doing the same, and you have something that you are comparing. You have some variables, so things that you are measuring, and you're measuring through comparison. So if I wanted to plant some seeds, and I wanted to know how much sunlight the seeds should have, then my control might be that I use the same type of dirt, I water the seeds the same time of day, I water them the same number of days, I water them with the same amount. Those are all the things that I'm doing the same. My variables would be amount of sunlight and plant growth. So I might put one plant or one seed, so I want it to be a plant, in direct sunlight, let it be exposed to sunlight 8 hours a day. I might plant some more seeds and put them in a pot that I only let out in the light 4 hours a day, and then I put it into darkness. So then, over time, I'm going to watch those seeds sprout, and I'm going to measure the growth of those plants. And then I'm going to be able to compare the one that was in sunlight all day long to the one that was only in sunlight for 4 hours a day. So those are my variables. So I am testing the amount of light on plant growth. So plant growth is going to happen in response to the amount of sunlight. That's my hypothesis. So therefore, growth is dependent. It's going to be the dependent variable, and amount of sunlight is going to be the independent variable. Now, measurement is the tool that I'm going to use to collect the data. So if I'm measuring plant growth and sunlight, the number of hours that the plant is in the sunlight, I'm going to measure that with a clock or some type of timer, like 4 hours a day versus not 4 hours a day, all day. So all day I wouldn't have to move in and out, but I just have to keep up with how long the sun was shining each day. You know, is it 10 hours? Is it 8 hours? What time of year, daylight savings time or not, would determine that. But I would be measuring plant growth, so I might just be using a centimeter ruler as my other tool and taking my measurements in centimeters. Now, as a scientist, using your tools is very important. Choosing the right tool, choosing an accurate working tool, using the tool accurately, measuring and recording units, all of those things are important. So for measurement, I don't have a picture here, but you can choose what you want to draw. Do you want to draw a ruler? Do you want to draw a balance? Do you want to draw a graduated cylinder? Do you want to draw a clock? So something to represent measurement. Now, that is where we're going to stop today. We'll start with qualitative and quantitative later next week. And right now, remember, your goal is to now, you've got a picture and a definition in every square, and you're going to come up with a sentence using the term and an example of when you would use it in a science classroom.